Hi there! In previous videos we discussed how to implement different types of checks and how to integrate it to machine learning pipeline on different stages, from data quality, data stability to data drift and models output checks like models output drift and models quality. Now it's time to discuss automation and see how we can integrate such checks into automated pipelines. Airflow is a very well known and popular workflow manager, which is widely used across different domain areas, right? This is open source tool, this is why it's quite interesting to see how we can actually integrate our checks into Airflow pipeline. That's the topic of our video. Prior to proceed to Airflow, I would like to mention that you need to have an access to running Airflow if you want to follow along with me during the video. And if you work in a company where there is already installed Airflow, just feel free to log in and play around with DAGs there. And if you do not do, I would suggest you to hit a pause on the video and install it. I'm going to quickly share some installation notes if you're interested in, and it will be related to Docker installation because I personally prefer to do it with help of Docker. Let me go to Airflow official website, and there they have very nice instruction. This is the how-to guide on running Airflow in Docker. They have a note that this procedure can be useful for learning installation, and I totally agree, because if you install Airflow locally on your laptop using Airflow Docker, or maybe just install each service inside of Airflow one by one, it will be quite convenient to play around with a couple of DAGs locally, but if you want to have a production Airflow graphs, then you would need two different installation, and of course it should be a production server. So, if you want to follow along, please install Airflow. Here is a quick instruction on how you can do it with help of Docker. I believe you can do it like in 15 minutes. And before you begin, it's crucial to install Docker to your laptop together with Docker Compose. Right? And later, after you install Docker, it makes sense to just follow this instruction. So, you will need to load docker compose.yaml file. And then you would need to follow the initializing environment steps. So they would ask you to create the following directories: DAGs, logs, plugins, and config, and then activate the Airflow UID. Right? So that's fairly simple, and I believe it takes not more than like 15 minutes. I already downloaded the Docker Compose file and installed it, and I already have my Docker container with Airflow running. Before we proceed, I would like to quickly mention that if you use the installation from Docker, you will have something like a virtualization, so you will not have any access to the Python libraries installed in your virtual environment or across your laptop from the Docker, right? You would need to install your Python packages inside of Docker container. For doing that, you can use the following instruction. This is a special case where you add dependencies via requirements.txt file. So that's exactly as we do for, let's say, virtual environments, right? I also created the requirements.txt file for our Docker example. There we have scikit-learn, we have pandas, we have numpy, and we have evidently, of course. So to do that, you would need just to follow the couple of steps in the instruction. Instead of using image, we would need to build our Docker container with Airflow locally, and for doing that, we will need to introduce a couple of changes in our docker compose.yaml file. They basically suggest to comment this image row and uncomment build row, and then add a Docker file with the following instructions. Luckily, I already did it, so if you want, you can create this Docker container file yourself and alter your docker compose.yaml yourself as well, right? Or you can go directly to the COROS repo and just load altered docker compose.file and Docker file, right? I'm gonna show you it now. So that's how it looks to me. I just commented this image row. I uncommented this build row, and it's totally optional, but I also created one more volume for evidently reports because I just prefer to store it in a separated folder. It's totally optional, but that's what I like. And yes, I just added one more directory here together with DAGs, logs, config, and plugins. It's also evidently reports, and I added it at the very end in volume section. So here it is. Well, in order to rebuild our Docker with the Python libraries, we need to create this requirements.txt. It also is in course repo, so we have only 4 Python libraries here. And here is the Docker file where we just add this requirements.txt file and we run pip install command, right? So that's it. After you altered Docker Compose, you created this Docker file and you added requirements.txt, it's all in the same directory. You could just go to a terminal and write and run Docker Compose up ---- build so that you can rebuild your containers. Let me do that. And you can see that the process of container building and running started. It should be comparably fast, especially if you do not build up your containers from scratch, but you already built it before. But now we rebuild it, so we need to wait. And yeah, it looks like it's almost done. Yeah, it's done. So we can see that it's listening, Airflow web server, so we can just copy the URL. Go to our favorite browser and follow the address. Yeah. Actually, I ran my Airflow before, so it doesn't ask me about the login and password, but if you do it for the first time, it will ask you. So the standard login and password are Airflow. If you changed it, you will have different ones. And here you can see the web interface with the example DEX. So if you never worked with Airflow before, you might be interested to browse in this example DEX and see how it works. Let me go back to the code, and I'm going now to start creating our own deck. I will try to comment as much as I can so that if you never worked with Airflow before, you can understand what's going on. But generally, our idea would be to create a pipeline which will contain 3 steps. One for load our data. We will use the same data set we used before, bank marketing data, right? The next step would be to analyze it for a drift. And if drift is detected or any drift-related test fail, we create the HTML report. If not, we just continue. So we proceed to the next step if there is any, or we just stop there. So that will be a very straightforward and small deck with 3 tasks. In order to make sure that our Airflow sees our deck, we need to create it under dex directory. So I'm going to create new file. And I will need to make sure it is saved in the correct directory. So I'm going to dex, and I'm going to call it conditional drift suite. Here it is, and you can see that it's under deck directory. And there I will implement more or less the standard Python script, but I'm going to import deck and Python operator from Airflow so that I can create the right object to be operated under Airflow manager. So let's do it. I will start from the importing of the libraries, a couple of standards like OS, pandas. I will also import datasets from scikit-learn so that we can access our bank marketing dataset. And I'm going to import test suite and data drift test preset from Evidently. That's more or less it. If you need anything else, I will add it later. And maybe the most interesting part here related to the Airflow. So I imported deck, which is the object which stands for directed acyclic graph. That's the object we are going to create, our main object. And each task of deck will be a Python function, so I imported this Python operator that I can later create a task using this Python operator. Well, that's it. Let us proceed to creating our deck. What's gonna be here? First of all, I would like to create a dictionary with the standard parameters for my deck, like owner, like begin date, retries, time delta, to specify how much time should pass before I retry to run my deck if there are any issues with the specific tasks. So let me create it first. I would call it default args, default arguments for my deck. This will be standard Python dictionary, so I just specify a couple of things. Start date doesn't really matter here because we are not going to actually schedule our deck. We are going to run it only once for the example, right? But if you are going to create a production graph, then probably you will have the start date and some schedule. So let me just add it for the sake of the example. And I would probably stop myself here. So that's default arguments, which I, for instance, can reuse between different decks so that I can create it once and then reuse. And I'm also going to create a couple of global variables for the folder with reports, because I'm going to store all my reports there. And I would create the variable for... Yeah, it's totally optional, but I prefer to have a variable for the name of my test suite to save, so let me create two. Here I would like to draw your attention to the fact that this directory should be called report, because I already used this name in my Docker compose file. Let me quickly remind you. So it was somewhere here. Let me scroll up. Yeah. So I connected my local evidently report directory with the reports directory from the container, right? And now if I'm going to use this reports directory, so all the content will be visible here in my evidently reports directory, right? So that's quite convenient things to have. Well, okay, I have my directory and maybe file path. Now I need to implement the tasks itself, right, so that I can run my deck, and I will create standard Python functions. So the first function will load data for me, and it will be the dataset from scikit-learn. The second function will calculate drift, so let me create a scheme of our deck. And the third function will be create a drift report. Then, after I implement each function, I will be able to create a deck, and let me start from the deck so that I can see the logic, and then based on this logic I will go and fill all the functions with the instructions. So my idea is to first load the data, then execute data drift analysis, and then conditionally run create report execute function which create report if it's needed. So let me implement such deck. So let us call our deck evidently conditional drift, right? And schedule interval. Let's have daily, but it's totally up to you. And I also would like to set catch-up parameter to false explicitly, so that if, for example, you specify the start date to the past, then your deck will not try to catch up with all the previous dates with your schedule, right? And it will not try to calculate the deck for all the missing dates, right? So it does not try to catch up here. And the structure. This is how we can create a task inside of our directed acyclic graph, and the idea is that we need to specify which operator should operate our task, right? And as we have a task implemented as a Python function, then we use the Python operator to actually run the instructions from our function. We need to create a task ID so that we can understand what's running now when we see the graph inside of Airflow, for instance, right? And the task ID would be load data so that we can understand what does it mean, right? Python callable, it's our function. Load data execute, we are going to implement it in a few minutes, and provide context. This is the parameter which tells that we actually need to provide the context for our task, and as we are going to use cross-communication mechanism to interchange data between different tasks, we need to have some task context where it can store needed variable, and from where we can derive those for our next tasks. So that's how we create a task inside of our graph. So let me create the next tasks, which will be drift analysis and create report. Again, Python operator, and let me change task ID to drift analysis. Yeah, looks like that's it. So we implemented each step in our deck, and now let's implement the structure so that Airflow can understand how to structure our deck. So what is the order between different tasks and whether there are some conditions or anything in the structure. So we start from load data. Then we go for drift analysis after we loaded the data. And finally, depending on the output of drift analysis step, we decide whether we run create report or not. If you want to say that this step is conditional, we need to use brackets here, square one. That's it. So now we have our graph, and all we needed to do now is to implement those Python functions so that we can actually run this graph. Let's do it. Here it is. We just implemented our load data execute function, and you can see that we use very similar instructions to we used before in the previous videos, right? So we just load our data from datasets, then we create a frame, and then we use this specific mechanism implemented in Airflow, which is called cross-communication. This cross-communication mechanism helps us to add something to TI, which is task instance. So we add something to task instance context. In our case, it's the bank marketing data frame, and we add it under a key data frame so that next task instance which share this context with the previous one can pull those data by the key data frame from the context, right? So that's how they share data. So now let's implement the second function, drift analysis execute, and here we're going to pull this data frame using key data frame. So you can see that I literally follow very same logic that we have in the previous videos. So we split our data into reference, production simulation part, and we say that batch size is equal to 2000. In the reality, when you have the pipeline, you would not be able to access the whole production data at once, right, and then get some batch. I mean, it's not like you won't be able to do that, but probably you'll use the whole production data you have at the moment, right, because you try to execute this graph for most recent data. But as we already have all the data at hand, we need to simulate this batch usage, so I select this batch size to have these batches. And now it's time to actually calculate this drift, right, and check the drift status. Here we go. So we just implemented the second function, which calculates drift suit for us. And as you remember probably from the previous videos, that data drift suit and any suit from evidently has this method addict, which transforms the output to Python dictionary, and then we can just derive any values by key, right? And we use key summary, then all passed, and if not all passed, so if all passed equal to false, in other words, we return create report task. So basically we trigger the next task which creates for us a report. So finally we just need to implement this create report function, right? And we will be able to try and run our deck. Let's do that. So just for the sake of time, I'm going to copy a couple of instructions so that I can do it a little bit faster, but it will look a little suboptimal. So I'm just going to copy the whole logic here. I could actually pass it through XCOM, but I just prefer to keep it simple. So all the logic here, and we need to also save now this report at our local directory. Well, I believe that's it. So we just created very same data drift suit, right? And we try to create the directory. It's the instruction which we need for the first run before we actually have this directory, right? And then what we do, we save our HTML, and here we create a path on the way with joining the directory path and the file path. Well, looks like that's it. So now let's try to save our deck and go back to our Airflow. So let me quickly update it. I'm not sure if it's able to add my example with hot reloading, so let me try once again. Yeah, I believe I would need to stop at least my installation of the Airflow so that it can check my new graph. For doing that, I run I run docker compose down first. It stops all my containers. Then you can see that it stopped here, and I would go back and up that again, but now I do not use the parameter build, right, because I do not need to rebuild it from scratch. So that should be much faster. Let's see. Yeah, looks like it's ready, and I can go back to the browser. Yep, here we are. Let us update. Now it asks us to log in, and login and password would be Airflow. I keep the standard one. Yeah, and you can see that here is the duck import error. Let us check. Yeah, okay, so probably, yeah, we just mixed up a little bit. So let's go to line 32. So you can see that it parses the code directly and gives us an error. So let's go back to line 32. Yeah. Of course, we did some copy-paste code, so we need to fix it everywhere. Let's wait a little bit. Yeah. Now there is no errors, and let us just order our DEX by the owner. So I added owner Emily, so it will be first. And now in order to run our deck, we can just trigger it and see what's going on. But before that, I want to quickly introduce to you how it looks like. So if you go to this graph tab, you will see the structure. So that's like 3 our tasks. Every task is operated by Python operator, and first we load data, then do drift analysis, and finally create a report. So that's very like small and straightforward graph. Now let's go back to the DEX, and I'm just going to trigger graphs. Oh, where it is? Yeah, again, order by owner, and let me trigger it. So we can see that 3 tasks were initiated, 1 running, already 3 successful, so it's very fast, right? But anyway, we can go there and see the summary, duration, it's super fast. So we can go there. I actually expect to see some information here. Maybe I can just quickly update. So I can see, yeah, just wanted to show to you the status success for every task. Yeah, here it is. So you can see that all finished. Now it's time to go back and see whether we had like drift detected and if there is a report here. So if we open up evidently reports, we can see that here is the data drift suite, but it's HTML format, so I'd better open up it in a browser. Let me do that. Yep. Go to the model 5, Airflow, and my evidently report, and you can see that it's just generated literally like 2 minutes ago. And if you open it up, you will see that, yeah, here is the some failed tests. This is why all past was equal to false, and we have this HTML report, and we can debug using this report because it has quite a lot of different visualizations which should help. And yeah, here is a summary of failed drift tests. So basically that's how you can integrate the testing into your Airflow pipelines. What is interesting here that actually you can create these conditional steps, right? And you can decide on the logic whether you need to proceed downstream the graph, or maybe create some additional reports, or maybe do some additional steps related to some debugging, maybe send in some alerts. And it's very, very convenient to just add some testing steps after the data processing steps if you do something which worth testing. Basically, that's all I wanted to share with you in this video. If you have any questions, do not hesitate to ask us. And let's proceed to the next one, where we are going to integrate some checks in a prefect.